Okay, so practice test for our third unit. We have a bunch of stuff in there on this property sheet. Okay, or on our practice guide, sorry. I'm going to zoom in here a little bit, make sure this gets a little bit bigger. Whoa, too big. All right, on the vocab, 3 words are not used. 3 words. Even on the practice guide, I made it that way. Test, same way. 3 words will not be used. So your third test, 3 words aren't used. So you have an extra word bank. Let's go through some of these definitions. So we have this, okay? Theorem 2.1. That's our first theorem we had on this chapter. It's the main one we had about a week ago. It was about midpoint. Midpoint means that 2 segments are equal to each other. So like it's M is the midpoint of A to B. Then AM to M is equal to MB, that type of thing. So that's theorem 2.1. So go find it, put it on there. Okay, let's go to postulate. Postulate is a mathematical statement we accept as truth. There's no need to prove it. So we accept it as truth without proof. That's a postulate. We've had a lot of postulates. In fact, up till right now, we've had, we've had 11 postulates. Think about that. 11 postulates. We had 13 theorems in this chapter alone. Okay, I'm only picking the big ones. So like when I know like you're thinking, oh my God, I could put 7 to 11 different postulates there. Now, I only pick the main ones. Like the ones I would be thinking of: segment addition postulate, angle addition postulate, midpoint was a big one because we talked about that quite a bit. Supplementary theorem and complementary theorem. Supplementary theorem and complementary theorem, the theorems we did yesterday, that was theorem 2.3, 2.4, 2.6, and 2.7. There's 2 sets. They all had supplementary and complementary. Those would be the big ones. And vertical, theorem 2.8. Okay. Let's keep going. Conclusion is the part of a conditional statement that follows the word then. It's information that follows then in a conditional statement. That's a conclusion. Symmetric is a property in math where you take the right and left sides of a mathematical statement where the right and left side have been switched. So usually they have to show you some form of math where they're doing something like this. Where they show you this, maybe in quotes, and on the other side, they do this. They switched it around. So you're probably looking for something that would have a mathematical statement. That's symmetric property. Okay? Just saying, it's probably better. Deductive reasonings, using facts, rules, definitions to come up with a logical conclusion, but it's memorization, so it's got to have facts, rules, definitions, properties to form a logical conclusion. Proof is a statement that uses logical reasoning to make conjectures. That's a proof. It's a statement when using logical reasoning to make conjectures. Conjectures are truths. Showing evidence, sometimes that's another one that they could throw in there, but that's the idea. Division property of equality. They would probably have to show, for division property of equality, they'd probably have to show you something like this in one of the quotes, and then the next quote over, they would have to show that they divided it by 3 to both sides. Like where they got rid of 3, or they divided by something. I don't know if you have that. And transitive is when they show a daisy chain of events. So transitive, it's when they do something like this. A is equal to B, and then B is equal to C, then A is equal to C. That's transitive. Complementary. What does complementary mean? We've had these theorems, but what does the word complementary mean?
2 angles whose measures have the sum of 90.
Yeah, sum of 90. You add up to 90. In fact, that was the theorem. That was theorem 2.4 and theorem 2.7. That was complementary theorems. They mean the same thing. They add up to be 90. Any questions so far? I've been blitzing my way through this, sorry. Good. Let's keep going. We're on bisector. It is a line, ray, or segment that cuts a geometric figure in half. That's a bisector. We had bisectors yesterday. We talked about it. Cuts something in half. Cuts it into two equal parts. That's a line, ray, or segment. Vertical angles. Vertical angles are angles that are formed by the intersection of two lines that are funneled together. I use the word funnel a lot. I talk about vertical. That was also a theorem of ours, theorem 2.8. Vertical angles are equal. That was the theorem 2.8. Hint, hint, hint. Subtraction property equality. They similarly subtractable sides. On that one, you'd probably have to show something like this. For subtraction property equality, they'd probably have to show you this idea, like they'd have this in quotes. Then after the word then, they would show you this. Or they similarly subtracted 3 to both sides. They'd probably have to show you something like that. So I don't know if there's any there. Hypothesis. It's part of the conditional statement that follows the word if. Now, there was one word I didn't have in here. And this is to make sure you're paying attention. So, where do you need to put in here is by condition. It's the only one we haven't had yet. I didn't put it in there, I want to see how many people are paying attention. We haven't had the word by conditional. It wasn't in our word bank. I threw it in there to see how many you were paying attention. Questions at all? Now, for vocab, oh yes, questions.
Wait, so we not use
4
then?
4 words.
Okay.
Now, vocab tomorrow. I already warned you of the theorems. Theorem 2.1, again, that could be fair game because that's the midpoint theorem. I could have 2, 3, 2, 4, or 2, 3, 2, 4, those are complementary and supplementary, no particular order. 2, 6, 2, 7, complementary and supplementary again, so you gotta know those words. Vertical theorem, any of the postulates, I could have segment addition, angle addition postulates, that was I think 2.9 and 2.11 for the postulates. Those are fair game. And then vocab words, definitely any of these. So like it could be, I can put hypothesis, I could put conclusion, I could put theorem. You know, theorem is like one of the words we talked about, like what a theorem means. That was on the last test, I think, or practice guide maybe. The properties of equality, like transitive, symmetric, reflexive, that type of thing. Anything that's really on your property sheet, I could put in there. So it'll be pretty basic. I'm not picking weird, obscure words. I'm picking words that we've used. So hopefully that makes sense to you. But tomorrow, I'm kind of warning you of this, that 3 words will not be used. And I want to do a thing where there's some weird guessing thing. I just want to see if you guys are paying attention today. We good so far? Let's move on. Let's go to number 2. Okay, these are the algebra problems. I tried to put a couple of these on here. These are where we can get some easy points. A lot of people are pretty good at this stuff. On test day, I will, I might give you a hint of how many steps it should take you. It may not be perfectly that many steps, but at least you'll be in the ballpark. Like if I was doing this problem right now, this should take you 3 steps. With properties, with all the math to get there. Shouldn't be just 1 or 2, it should be 3 steps. The one down here, since it's an equation, these will take different properties, right? This should take us 8 steps. That's a pretty basic equation. These are the 2 I want to get through today. Like I want to finish this first page, and then tomorrow we'll do the second page. Now I know there's one at the bottom still. It basically uses the same concept. It's a geometry proof that uses algebra. Okay, now these 2 are just algebra, so we're going to just start doing math, and as we go, we just put the reasons down. I'll try to pick pretty basic ones like this. I consider these easy when you start going through them. But let's walk through number 2. I'm going to blow these up so they're a little bit bigger. I like how small these are right now. I'll have to deal with this. It's not as big as I wanted it to be. Okay, what do I have to do first? If we're doing all the steps, no shortcuts.
Given.
Given, okay? So we have our given, boom, it's right there, right? In fact, I'm just gonna write that, so this is our given. Okay, I agree with that, that's fine, you can put that, you don't need to, but I'll agree. That is the first step. What would be the next step? What do we have to do in the math now?
the 6x and the 2x together?
Yep, 6x, negative 2x, we have to move them next to each other, move the 9 and 7 next to each other. What is that called when you start moving stuff around?
Commutative.
Commutative. It's commutative. Boom. You move them around. Yes, you do have to show those steps. So this is a commutative property, it's not a distribution property. Distribution would be the other type of problem I could put here. I could put a problem like this. That would be the other type of problem I could put, where you have to show me that you can distribute correctly in the sub. So, this would also take about 3 steps if you do it correctly, the same, maybe even 4, but 3 steps. So that's the type of problem I would put here, it's one of these two. Okay, so let's keep going. So now that we moved them, we cannot just add the x's. What do we have to do first?
Put them in parentheses.
Put them in parentheses, yeah, we have to take out the x. Now this property, when you take out the x, is not associative. We didn't have parentheses, we had to take it out. What is it called? Factoring, reverse distribution, that's what it is, or factoring, distribution, or reverse distribution, I'll just call it factoring. A lot of people forget that step. You have to take out the x before you can add them together. They can't even see each other, the x's are blocking. So you have to get the numbers next to each other, then we can do all the math. What's 6 minus 2? 4. 9 plus 7? 16. And that's sub. When you do simple kind of math, substitution. I prefer that you don't abbreviate, try to write down the words, substitution. Do it myself. Alright, do you feel comfortable with like the 3-step process?
Yeah.
Okay, now if it was this problem, like let's say this is the problem that's in there, because these are the only 2 I'll pick for number 2. Because these are the 2 that we spent a lot of time on. We spent like a week doing this stuff. We even had little like games where you had to try some out and hand off the paper to somebody else. Okay, this is the other type of problem. First line is given. Okay, you have it. Boom, there it is. Next step, what do we do? Distribute. And that's the actual property name. We hand out the 3 to everything. But notice, I'm not just writing, 12 and 24. I'm not doing that. Well, I have to hand the 3 out to everything. That's distribution. Where you hand it out. Now, when you do distribution, we do have to switch the parentheses around, right? So what will it look like if I switch parentheses? What should I have?
3 and 4 in the parentheses and x outside.
Exactly. That's the number one thing I want to make sure. The x has to be on the outside. The 3 and 4 are in by themselves. Same with the 3 and 8. So 3 and 8 are in Z with each other. That is called associative. Because you had parentheses and you moved them. It wasn't like factoring where you had to make it up and pull the x out. It's different. Okay, we only have 2 steps and they're basically the same property. What do I get? What's my math? 12x, keep going. 24. And last step? 34. These are both substitutions. They're both the same property. I'm putting them in the same color. They're both substitution. They're both. Just because I'm doing simple math. Okay, I consider that 3-step type of problem, it's the same property. Now, if there was like x's over here, then you'd have to do more. You'd have to move stuff around. I will probably not do that. I'll probably pick a 3-step problem. Something very, very basic. Because I just want to see, do you know the basics? Okay, we're good with number 2. The type of problem I can put there, or if it's that one, just know how to do that. So these are both fair game, because that's the 2 problems. We did a ton of those in class. I'll pick something basic, something easy, no crazy numbers, nothing like that. Okay, we're good? Okay, let's do the last one here today. I want to do number 3. Kind of walk you through it. This will be your last one today for timing wise. Now I know that's not the last one on this page. There's a number 4, but all the rest of them after today is like geometry based problems, so I thought we'd just do those tomorrow. Or Monday, I should say Monday. Alright. So,
This week.
number 3. Okay, I warned you this should take us 8 steps. 8 steps through this problem, because it takes 4 lines of work to go through every part to get rid of those numbers. I will have that general outline of like the 4-step process on the board. when you do algebra like this. It probably, on test day, it'll probably up here for you guys, because everything else will be on the board. Like that's the outline for geometry proofs. This will be the algebra proofs. I'll have several pre-calc back there on test day, so just kind of be aware of that. So, all right, let's keep going here. I better put the outline. Outline, we have to do a property of equality first. Prop of equality, some property of equality. And now, if you were in class those days, I did talk about like which ones you have to pick. Like if you add or subtract, you go down this rabbit hole. If you go down multiplying and dividing, you have to go down this rabbit hole. That's not the term I'm gonna put on the board. It'll be just this general outline. Like step 1 is property of equality. Step 2 is some type of inverse. There's 2 inverses, and if whatever rabbit hole you're in, that's the one you pick. 3 is some type of identity. And yes, you have to tell me explicitly which identity is same with the inverse, like there's 2, you have to pick one. And then number 4, it's some type of substitution. That's usually the order we go in, okay? Basically, that's what it's gonna look like on the board. I'm not giving you the specifics. So you can't just write those and expect to get property names right. You have to give me what explicit one is which, okay? So let's do this problem. We'll go through the first 4 together right now. Okay, first step, what do we have? Subtract 4. Okay, we're going to show subtracting 4 to both sides. That's the property of equality. So the simple fact that I just said I'm subtracting, that's the property name. That's subtraction property of equality. Subtract prop of EQ. Hopefully this is starting to click again like what we did, because we did so many of these, so you guys got actually really good at this for a while. Got to recall how to do it. Okay, we're good so far? Okay, so we did the property of equality, now we're moving on to inverse. Now if we know we're adding and subtracting, right? So the inverse we should be doing for adding and subtracting is the property of opposites. So what do I get when I go 4 minus 4? 0, we have to put that in there, that's the full step. You have to put 0 on the other side, I'm not gonna subtract yet. That's property of opposites, that's the inverse that you have now. Now, property of opposites. Property of opposites. That's the rabbit hole, because if I know I'm adding and subtracting first, it's property of opposites. If I was multiplying or dividing, then that's reciprocal rule. That was the rabbit holes we talked about in class we took notes. Okay, next we add the 0. What do I get? What's 3x plus 0? 3x. 16 minus 4. That's an identity. Well, what did I just say? What type of math did I just do? Let's add identity. And again, if you're checking the rabbit hole properties that we talked about in class, like which one you pick, it was very explicit. Like you looked at which one you were doing. And the last step, now I can substitute. Let's get my answer. What do you get when you take 16 minus 4? 12. 12. So 3x equals 12. Alright, that's substitution. Now I'm not done, that was just the first 4 steps. That was half the problem. Okay, so then the second half is going through the same order again, but now you're trying to get rid of the 3 now. So now you're in the other rabbit hole, where you're now doing multiplying and dividing. And then you'd be doing, reciprocal and multi-identity and sub, like those are the property names, by the way, I just gave them to you. Okay, you guys think you can finish that problem up? I just said the property names. Okay, do that right now, finish it up. This is your last one today. If you want me to double check that your work is correct, I'll do that. You have about 5 minutes. You can kind of work on this and see if you get it right. Just wait 5 minutes. So try to work on this. Try to get those next 4 steps. I'll check your property, make sure that you have the right one. But it should be 4 steps. I have the order up here on the board. Again, that'll be their testing. Test day on Tuesday, remember that. This practice guide is due Tuesday. So get it turned in, it has to be done. So I would recommend, like, if you know you're that person that loses it, turn it in Monday. But these problems are the ones that require all the steps. Like you have to get them every step. The geometry ones we can do shortcuts. I'll kind of tell you that tomorrow when we start going through. Okay, today, I know that today we have the pep rally, or not pep rally, but the assembly today for the Veterans Day program. Make sure that you leave your cell phone in period 4's class. I kind of went over that yesterday. So whatever period 4 class you have to dock that phone in the caddy and they'll stay there. The doors will be locked, teachers were instructed to lock it, so that your phone isn't getting taken by somebody, so. But that's just out of respect for the veterans and all our community members that are there. And if somebody has their phone, make sure that they turn it off.